Of the topics, whatever we have learned, let's apply it on the problems. Look at the first one. A coin is tossed twice. What is the probability that at least one tail occurs? Okay, now you need to understand a very important word here, that is at least. It's a very, very important word. All right. The reason why we say at least is important because it can be more than one. That's why first thing what we need to do is we have to write the sample space. So sample space is going to be S is equal to HH, HT, TH and TT. Okay. And the event E is equal to at least one tail. Okay, so it's not one head, sorry, it's one tail, at least one tail. Well, the probability remains the same, but of course the question is going to be different. At least one tail. Okay, now when we say at least one tail, let's encircle what are the possible choices. At least one tail. This is one. This is one. This is one. Correct? So there are three possibilities. So we can say P of E is nothing but N of E divided by N of S, which is going to be 3 divided by 4. So P of E is equal to 3 by 4. That's it. This is the answer for the first one. Very simple. Alright. Let's move on to the second one. See the second one. A die is thrown. Find the probability of the following events. The first one. So before the first one, I think it's safe to say that we need to write the sample space, correct? See, sample space is going to be 1, 2, 3, 4, 5 and 6. Because a single die is thrown. First one, a prime number will appear. Guess what are the prime numbers here? Very, very important. Correct? See, when we look at the prime numbers, 2, 3 and 5. These are the three prime numbers. So we can say the event, or you can say N of E is equal to 3 numbers. Correct? And N of S is equal to 6. So P of E is equal to 3 by 6, which is 1 by 2. So probability of having a prime number is going to be half. Alright, next, second one. A number greater than or equal to 3 will appear. Greater than or equal to 3. So how many numbers? 3, 4, 5 and 6. There are 4 numbers. So N of E becomes 4. Of course, N of S is 6 itself. That's not going to change. So P of E is going to become 4 by 6, which is 2 by 3. So second one answer is 2/3. Next, third. See, third one, a number less than or equal to 1 will appear. See, less than or equal to 1. Equal to 1 is possible, but do you have a number less than 1? No, right? So, N of E is just 1. That too not less than, but equal to condition. That's why it's only 1. So, P of E is going to become 1 divided by 6. Correct? See the fourth one, fourth sub question. See, a number more than 6 will appear. Now, do you have a number more than 6 anywhere here? No, right? So, N of E becomes 0. So, probability of the event is going to be 0, which basically is an impossible event. Fine? Now, the last one, fifth one, a number less than 6 will appear. See, number less than 6, not less than or equal to 6. So, since it is less than 6, 1, 2, 3, 4, 5. 5 numbers are there. So, N of E is equal to 5. So, P of E is equal to 5 divided by 6. So, this is the answer for the second one. Fine. Let's do the third question now. See the third one. See, for the third one, a card is selected from a pack of 52 cards. Correct? So, we are selecting one card. since we are selecting one card, we can say that the sample space, not P of S, N of S. N of S is equal to 52 C1, which is nothing but 52 itself. Okay. Now, the first one, how many points are there in the sample space? How many points is nothing but how many cards are there in the sample space? Answer is just 52 C1, which is nothing but 52. Correct? Very simple. The next one, calculate the probability that the card is an ace of spades. See, if you don't know the structure of the card, there are 4 suits and each suit has 13 cards. Of the 4 suits, one of the suits is a spade. Okay. Now, spade has one ace. That's all. So we have probability P of E is equal to 1 out of 52. That's all. Alright. Next, the third one. Calculate the probability that the card is an ace and a black card. Okay, like I told, there are 4 suits, correct? So the 4 suits are, so see, in this 4 suit, the first one is a spade and we have club. These two are black colored cards and the other two are hearts and diamond, or you can say dice. These are red cards. Now this has 13, this has 13. Likewise, this has 13 and this has 13. So in total, you have 52 cards. So this is basically one pack of cards. Now the third one, what is the probability that the card is an ace? Now each suit has one ace. Okay, each suit. That means the first one, there are 4 suits and each suit has one ace. So we are going to have 4 out of 52, or you can say 1 by 13. This is the answer for the first one. And for the second one, probability of finding a black card. So total of 26. 26 out of 52, which is going to be 1 divided by 2, half. Because 26 black, 26 red. So it's going to be 52 cards. So probability is going to be half. Fair enough? So this is the answer for the third question. And now let's do the fourth one. See the fourth one. A fair coin with 1 marked on one face and 6 marked on the other and a fair die are both tossed. Okay. Find the probability that the sum of the numbers that turn up is 3. Okay. See, for the coin, we can say that probability of getting 1, this is half, correct? And same way, probability of getting 6, this is also half. Well and good. Now, when you roll a die, there are 6 sides of a die, correct? So, probability of each and every number, that is P of 1 is equal to P of 2 is equal to P of 3 till P of 6. All of them are 1 by 6. I hope this is clear for everyone, right? Now let's solve with the problem. The first one is, what is the probability that the sum of the numbers that turn up is 3? If it has to be 3, then there are 2 possibilities. I can say that there is only one possibility which you will understand. That is, the coin has to have 1 and the die should have 2, correct? That's the only possibility. I mean, you cannot have 1, 1, 1. That's not possible. 1 and 2. That means what we have is that we should have probability of getting 1 on the coin and 2 on the die. This is what we are looking at, correct? So probability of getting 1 on the coin is 1 by 2 and into getting a 2 on the die is 1 by 6. So this is going to become 1 divided by 12. So the first one answer is going to be 1 by 12. Fair enough? Same way, if you look at the second case, that is the sum should be 12. right? If the sum has to be 12, then probability of getting 6 on the coin, because only 6 plus 6 can give us 12, correct? 6 on the coin and 6 on the die. 6 on the die. So which is going to be half into 1 by 6, which is going to be 1 by 12. So these two are equally likely events. Alright, so equally likely. Both the answers are 1 by 12 and 1 by 12. Fine. Now let's do the next one. Look at the fifth one. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. Okay. And if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? Okay, now this is where you need to understand about permutations and combination. Because out of those 20 numbers, or the 20 numbers or digits or whatever, the person is choosing 6, correct? Remember, choosing selection. So we have totally there are 20 numbers, correct? N is equal to 20, of which we are selecting 6 numbers, isn't it? So what we have is NCR is equal to 20C6. 20C6 is the number of possibilities of choosing those numbers, or you can say the total possibility, because there are 20. See, out of 20 you're selecting 6 of them, isn't it? And it can be any 6. We are not choosing all 20 numbers, isn't it? So out of those 20, we are going to look at so many. But also very important is that we have to look at the order in which the digits appear, because it's a lottery, right? So 1 2 and 2 1, they're different. So when you do 20C6, what you also do is into 6 factorial. In other words, we are not doing NCR into R factorial, which is nothing but NPR. So technically, the sample space is going to become 20P6. Understood? So it's 20P6. This is the value. Now, number of possibilities, what? The match with all the 6 numbers. That means N of E is just 1. That means out of all those possibilities, there's one number which is going to match, isn't it? Just one combination. It can be like 2, 2, 5, 4, 8, 4, something like this. Okay. So if my number is 2, 2, 5, 4, 8, 4, I have to choose that number 2, 2, 5, 4, 8, 4, correct? Isn't it? So getting that number, we have only one chance. So N of E is 1. But how do I choose those numbers? This is the case. So we are going to have probability of the event is going to be 1 divided by 20P6. Of course, it's going to be a huge number. So let's keep the answer at this. So this is the answer for the fifth one. Now let's go for the sixth one. See the sixth one. E and F are events such that we have P of E is equal to 1 by 4, P of F is equal to 1 by 2, and P of E intersection F, because it's P and F. This is 1 by 8. Correct? And what are they asking? The first one is P of E union F. Very, very simple. Formula is what? P of E plus P of F minus P of E intersection F, which is going to be 1 by 4 plus 1 by 2 minus 1 by 8. Or you can take 8 as the LCM, which you're going to get it as 2 plus 4 minus 1. 6 minus 1, 5. Answer is 5 by 8. So answer for the first one is going to be 5 by 8. Very simple. Second one, you have P of E complement intersection F complement. Isn't it? See, first what we'll do, if you need this one, P of E complement and F complement. So first and foremost, we have to calculate what is E complement, right? See, if P of E is 1 by 4, then P of E complement is going to be 1 minus 1 by 4. That means here, see what we have. P of E complement is 1 minus P of E, isn't it? Which is 1 minus 1 by 4, 3 by 4. Likewise, P of F complement is going to become 1 minus P of F, 1 minus half, which is half. Now we have complement of these two, isn't it? See, when we have P of E complement intersection F complement, we can also write this as P of E union F whole complement. If you remember, this is the De Morgan's law, which you have learned last year. So E union F whole complement, so which is nothing but 5 by 8. 5 by 8 is what? P of E union F. So 1 minus 5 by 8, which is going to be 3 by 8. So 3 by 8 is the answer. Either you can use this one, or you can also use P of E into P of E complement into P of F complement. That's 3 by 4 into 1 by 2, which is 3 by 8. I mean, both of them will work. I'm just giving you different options of solving. That's all. All right. Either you can do normal multiplication, or you can use De Morgan's law. Fine. So this is the answer for the 6th one. Now let's go for the 7th one. See the 7th one. A and B are even such that P of A is equal to 0.42. P of B is 0.48. And P of A intersection B is 0.16. Correct. First one, P of not A is complement of A. So the first one is going to be P of A complement, which is 1 minus 0.42. 1 minus P of A, correct? So 1 minus 0.42 is 0.58. So this is the answer for the first one. Simple. Next, second one, P of B complement, 1 minus 0.48, which is 0.52. Second one. Third one, P of A or B. That's P of A union B. Formula P of A plus P of B minus P of A intersection B, correct? Which is going to be 0.42 plus 0.48 minus 0.16. Correct? See, 0.42 plus 0.48, or we can also do 0.42 plus 0.32. 0.48 minus 0.16. So if you add this one, you're going to get 0.74. So this is the answer for the 7th one. Normal formula, direct just addition and subtraction, nothing else. Very simple. All right. Now let's do the 8th one. See the 8th one. In class 11 of a school, 40% students study math. So I would say that P of M is 0.4, 40%, right? 30% study biology. P of B is equal to 0.3. 10% study both. That means P of M intersection B is 0.1, 10%. If a student is selected at random from the class, find the probability that he will be studying math or biology. When you have or, isn't that union? So they're asking you to find P of M union B. Guys, direct formula. What is there in this direct formula, isn't it? So you're going to have 0.4 plus 0.3 minus 0.1, 0.7 minus 0.1, which is 0.6. Or we can say 60%. So probability that the person or the student selected will study both, so not both, mathematics or biology is going to be 60%. That's it. Fine. Let's do the next one. See the ninth one. Probability that a student will pass the final examination in both English and Hindi is 0.5. Correct? So, probability of passing in both English and Hindi. So, it's intersection. This is 0.5, 50%. Correct? And probability of passing in neither is 0.1. So, probability of neither in English nor in Hindi, isn't it? So, this intersection, this one, this is going to be 0.1. So, probability of passing an English exam. So, P of E is 0.75. What is the probability of passing in Hindi? P of H they are asking. Right? So, guys, P of E bar intersection F bar. P of E complement intersection F complement is nothing but P of E union F whole complement. Okay. So 0.1, this is nothing but 0.1. So P of E union F becomes what? This is going to be 1 minus 0.1, 0.9. That means the probability of passing in English or Hindi is 0.9. That's 90%. Right? Formula, again, the formula is going to be P of E union F is P of E plus P of F minus P of E intersection F. Right? Now, what we need in this case, oh, it's okay, it's Hindi. So, sorry, not F. It's going to be E union H. Okay, so everywhere this is not F, this is supposed to be H. Okay, so this is nothing but 0.9 is equal to 0.75 plus P of H minus 0.5. Okay, so 0.9 is equal to 0.7 plus P of H, oh sorry, 0.25, 0.25, 0.75 minus 0.5 is 0.25. So what is P of H? P of H is equal to 0.9 minus 0.25, isn't it? So 0.9 minus 0.25 is going to give us 0.65. 0.65. So probability that he is going to pass the Hindi exam is so much, 0.65, or you can say 65%. Fair enough? Now let's do the 10th one. See the 10th one. In a class of 60, so sample we have n of s is equal to 60. 30 opted for NCC. So we can say n of a is 30 and NSS is 32. 24 opted for both. So n of a intersection b is equal to 24. Okay, so we have all the possibilities now. Find the probability that the student opted for NCC or NSS. NCC or NSS, correct? First, what we need is, we need to calculate n of a union b, which is nothing but n of a plus n of b minus n of a intersection b. Okay, so n of a plus n of b, that's 30 plus 32 minus 24. So that's 62 minus 24. 62 minus 24 is going to give us 38. So n of a union b is this, but we need the probability of that event, isn't it? So P of a union b, 38 out of 60, or we can also tell 19 out of 30. So 19 by 30 is the answer for the first one. So we can write this is the answer, 19 by 30. Fair enough? Let's do the next one. See, for the second one, how many students opted for both? 38, correct? Because just now we did it. So how many of them are neither? So what we are going to do, we have 38 students. See, n of A union B is going to be 38. Or probability of A union B is how much did we get? 19 out of 30, correct? Isn't it? Now what do we need? We need P of A union B whole complement. Neither this nor that one, isn't it? So what do? We do 1 minus 19 by 30, which is going to be 11 by 30. So answer for the second one is just 11 by 30. Very, very simple. Fair enough? Now let's do the last one. See the last one. The student has opted NSS but not NCC. Basically, the difference we are trying to calculate. See, NSS is our set B, correct? So N of B is how much? N of B is 32. And N of A intersection B is how much? 24. Correct? And what is N of B minus A? 32 minus 24, which is 8. Correct? So there are 8 kids who have taken only NSS but not NCC. So what's the probability? So P of B minus A is going to be 8 out of 60, which you can say 2 out of 15. So answer is going to be 2 by 15. Clear? So this is the answer for the third one. So whatever the concept we have learned so far, see complement or A union B, A intersection B, complement of a set, that is A complement intersection B complement. We have covered all the concepts of probability what you have in this chapter. Fine. So in the next one, let's sum up as to what we have learned in this chapter.